All right, guys, here we go with Chapter 2. Chapter 2 is all about solving equations. So here in Lesson 2.1, we're solving a one-step equation. After this lesson, I will be able to solve a one-step equation in one variable. So here we go. Let's take a look. The diagram shows the amount of money that each player starts with in a video game. To be fair, each player should have the same amount of money. What amount must be in the chest? How do you know? So I have a collection of coins here for player number 1, and for player number 2 I have a bunch of coins, but then I also have this mystery chest, and my job is to figure out how much is in the mystery chest. Well, if we look at the left side over here for player 1, they have a total of 10, 20, 30 coins, and then if you look over here for player 2, they have a 5, 7, 8, 10, 11 coins plus whatever in the mystery chest. So really, if we make a little table, the left side has 30 and the right side has 11 plus whatever's in the chest. So using my math skills, I could just make an easy equation. I want the left side to be the same as the right side, so 30 has to equal 11 plus C. So 11 plus what number makes 30? Well, obviously C would be 19, because 11 plus 19 makes 30. So the chest must be worth 19. Okay, and that's the idea behind here this lesson. So equivalent equations are equations that have the same solution. We can find the solution of a one-step equation using the properties of equality and inverse operations to write simpler equivalent equations. All right, so there's 4 properties of equality, one for each of our standard operations. So the addition property of equality is adding the same number to each side of an equation produces an equivalent equation. So in symbols, if A is equal to B, well then A plus a number is equal to B plus that same number. For example, if x minus 3 is supposed to be 2, well then I can add the same number to both sides. In this case, we chose to add 3 to both sides, and then we would still get the same solution. So in this case, 5 minus 3 is 2. If I add the same number to both sides, x would still be that same answer of 5. So I can add the same number to both sides. Likewise, I can subtract the same number from each side. Okay? So if I have A is equal to B, then A minus C is equal to B minus C. So if I just subtract the same number from both sides, I wind up with the same solutions. So x plus 3 is 2. All right? So then if I subtract the same number from both sides, I would still wind up with the same solution. In this case, negative 1 plus 3 makes 2. And if you check this, negative 1 plus 3 minus 3 is equal to 2 minus 3. So I would get the same solution. So these are equivalent equations. All right, so addition and subtraction work. Multiplication also works. So multiplying each side of the equation by the same number produces an equivalent equation. For example, if A is equal to B, then A times a number is equal to B times that same number. So for example, if we had x divided by 3 is 2, well, then I could easily multiply both sides together by the same number and get an equivalent equation. 6 divided by 3 is 2. 6 divided by 3 times 3 is equal to 2 times 3. Okay? And then likewise for division, dividing each side by the same number produces an equivalent equation. So if A is equal to B, then A minus A divided by C is equal to B divided by C. So if I had 5x is equal to 20, well, an easy thing to do would be to divide both sides by 5 to get the x all by itself, and I'd wind up with the same solution set. To solve an equation, the first thing we must do is isolate the variable. We do this by getting the variable with a coefficient of 1 alone on one side of an equation. So solving an equation is just a series of these steps that as I work to get the variable all by itself, and then the last thing I normally do is divide to get the coefficient on that variable to be a 1. Isolate a variable using our properties of equality. Those are those 4: addition, subtraction, multiplication, and division, and inverse operations. An inverse operation undoes another operation. So, for example, subtraction undoes addition, and division undoes multiplication, and squaring undoes square rooting. So those are some common ones. When we solve an equation, each inverse operation that we perform should produce a simpler equivalent equation. Okay, so I could just keep doing these things, but it's not going to do me any good if I'm not getting closer to my goal of isolating the variable with a coefficient of 1. So here we go. We just have a bunch of practice. So what is the solution of x plus 13 equals 27? Well, since it's x plus 13, I want to undo that addition. So if I go to undo that addition, remember you have to do the same thing on both sides. So I like to draw this kind of little fence line, and to remind myself, whatever I do on the left, I also have to do on the right. So if I'm undoing adding 13, I would subtract 13. Remember, whatever you do on the left, you have to do on the right. So I subtract 13 from that side, I get x is equal to 14. Okay, pretty straightforward. Here in number 2, the solution of negative 7 equals b minus 3. Well, so again, if I kind of like to think of it as two different sides to the equation. I want to get the b all by itself. The b is on the right, so I got to get rid of that minus 3. Well, in order to get rid of a minus 3, I want to add 3 to both sides. And then I would have the b all by himself, and b would be negative 4. What is the solution of 4x equals 6.4? Well, 4x is really 4 times x. So in order to undo a multiplication of 4, I would want to divide by 4. And whatever I do on one side, I have to do on the other. 6.4 divided by 4 is just 1.6. So I'm able to isolate the variable with a coefficient of 1 and simplify the equation. What is the solution of x divided by 4? Remember, that fraction bar is a division sign. So to undo a division, I would always do a multiplication. So to undo dividing by 4, I would multiply by 4. Whatever I do on one side, I have to do on the other. And x is simply negative 36. Okay? When the coefficient of a fraction, when the coefficient is a fraction, we can use the reciprocal of the fraction to simplify the equation. Remember, reciprocal is taking the fraction and flipping it. So they asked me for the solution of 4 over 5m equals 28. So a one-step way to handle that would be to multiply both sides by 5 over 4. That's the reciprocal of 4/5. Remember, you have, whatever you do on one side, you have to do to the other side. And 5 over 4 times 4 over 5 is just going to get you 1. So you'd wind up with 1m, and then you'd have 28 times 5 over 4, which is just 35. Okay? Really, 28 divided by 4 would be 7 times 5, 35. Okay? That's one way to do it. I like to do it another way. I like to get rid of the fraction as soon as possible and then just solve what's left. So what I would do is I would multiply the whole problem by 5. That'll get rid of the denominator because dividing by 5 and multiplying by 5 are inverse operations. So I'm just going to take care of that part. Remember, whatever I do on one side, I have to do on the other. And all I'd be left with is 4m equals 140. And then now I just have a simpler equation that I can simplify. 4 times m is 140, so divide both sides by 4, and m would be 35. So if you can handle the reciprocal idea, do that. For me, I just multiply through by the denominator and then go from there. All right. So here's another example of that same idea. Okay. So 12 equals 3 over 4x. I want to get rid of that divided by 4. So I'm going to multiply the whole problem by 4. Whatever I do on one side, I have to do on the other. So 3 over 4 times 4 is just going to give me 3. So I'd wind up with 48 equals 3x. And now I have a simpler equation. Divide both sides by 3, and x is 16. Okay. There's a lesson check on the bottom of your sheet. Please handle that. So that'll be our way to see if you are processing what's going on. And that's it for lesson 2.1. I'll see you next time. Peace.